an F6AJA, and an AJO, depending on what manufacturer you're actually dealing with. Let's get this thing started. So let's do a little bit of housekeeping itself first before we actually start. I'd like to give a shout out to the folks from CL Aftermarket Products for sponsoring our webinars. We certainly appreciate their continued support in our webinar series. If you're having any sort of connection issues, make sure that you're on a hardwired connection rather than a wireless router type connection. We've had some problems with that. On the handout, everybody should have had access to the handout. It was on the main website itself as a PDF format handout. If you're having some troubles, you can go back to the website itself and see if you can download the handout. If you still have some troubles, you can give Lance a call. He's down at the office there in Oxnard, or Sean at the office in Oxnard. Either one of those will be able to get a copy of the handout for you. If you're having any questions as we're going through this stuff today, feel free to ask them. The simplest way to do that is to simply click on the questions box, type your question in, hit the submit key, and it's going to automatically pop up on my screen. When we're all said and done today, we're going to have a survey. Again, I appreciate you filling out that automated survey. That kind of tells us how the audio and video portions of this presentation went. So with that said, let's take a look at the JF613E. As we talked about a little bit earlier, there are several applications, both obviously in the United States as well as in Europe, that use this particular application. This is a Jatco built unit. So J stands for Jatco, F of course is front wheel drive, 613 is of course the model, and E means electronically controlled. So this is going to be a 6-speed unit. Again, known by different names depending on which brand you deal with of vehicle. So it's kind of important to know that an RE6 is the same as an F6AJA transmission itself. So with that said, again, none of us like obviously the confusion that the Asian market creates for us, but it's just kind of how it is. When we look at the clutch apply charts themselves, you're going to notice those apply charts are very similar to the apply charts you have for a lot of the domestic 6-speed transmissions. The clutches are named after what they do, so it makes it much easier diagnostically to go through the diagnostic process when you're trying to obviously diagnose an issue with a clutch slipping or a no apply type of condition. The solenoids are where the workload is done in this transmission, and this is about the only area that's going to really stump anybody would be in the solenoid area, so we're going to spend a little bit of time there discussing it. You've got 6 pulsive modulated solenoids, and you've got 2 on and off solenoids. The 2 on and off solenoids, as you can see, are the low shift solenoid and the low reverse brake solenoid. Standard resistances on those are about 30 ohms, so again, nothing different than you would typically find with other transmissions that are out there. Your PWM solenoid, you're going to find 2 vintages of those. One are normally high and the other styles are normally low. So when we talk about this linear solenoid or the PWM style solenoids, as I just said, there are 2 vintages of them, the normally low and the normally high. What they're referring to is they use Bosch nomenclature to determine obviously how they determine the solenoid information itself. And the basics of this thing is a normally low solenoid means that if you're not doing anything to the solenoid, so the solenoid's fully shut off, you're going to have low pressure as your output for the solenoid. A normally high, of course, would mean if you are not doing anything to the solenoid is turned off, you're going to have high pressure as your output. Now, it comes to reason that obviously these solenoids are non-interchangeable because they're going to work basically backwards of each other. So again, that's something real important to keep in mind is the solenoids themselves, you do not want to interchange or intermix solenoids, whether it's going from normally high to normally low or even changing the solenoid from bore to bore. These solenoids are flow tested. The only way that anybody sells these right now, I talked to the Mitsubishi dealer yesterday about it, is to buy a complete valve body. So you cannot buy a solenoid at this point as an individual solenoid because, again, they're matched to the valve body by Jatco. You'll see some markings on the solenoids themselves that will denote those flow characteristics of the solenoid. Again, those are Jatco proprietary numbers. We don't have access to their information itself for figuring out what the flow rates of the solenoids actually are. When you look at the normally low solenoids, like we're looking at here, you can see you've got a low clutch solenoid, a 2/6 clutch solenoid, and a lock-up low reverse clutch solenoid. The big thing here, guys, is that this is kind of like a Chrysler unit where you're going to use one solenoid to do 2 functions. That's what that job of that low reverse lock-up solenoid actually are. So you guys have been used to having this in the Chrysler family for quite some time. So effectively, there's not much different here. When we look at the normally high solenoids, there, as you can see on the right-hand bank of the valve body itself, again, so the bottom line is that when the solenoids shut off, there will be high pressure. High pressure is your output, and again, the right-hand bank is showing you the normally lows. The left-hand bank is always going to show you the normally high. So we're looking at a 300 RPM or 300 hertz fixed signal itself for the solenoids, and we simply vary the duty cycle to vary the output out of the solenoid assembly itself. Now, when you look at the normally high solenoids, as you can see on the left-hand side of the valve body, those are your normally highs. Again, if you have the solenoid shut off, you're going to have high pressure as your output for the solenoid itself. Again, you're going to have a high clutch solenoid, a 3-5 reverse solenoid, and a line pressure solenoid. The resistance of those solenoids is about 5 ohms, which is, of course, pretty standard of any type of PWM solenoid that you're going to run into. So, again, nothing razzle-dazzle or obviously anything to be concerned about when you're talking about these solenoids. Big thing is to keep the solenoids with their prospective bore so that you, in turn, can get them back in the same hole they came out of. When you look at the individual operation of the solenoids, it's pretty darn simple. Here you're looking at the on-off solenoids. The left-hand picture is showing you the solenoid turned into the off position. When the solenoid is turned into the off position, as you can see, the ball is physically blocking the port, so pilot pressure can't get through the solenoid. When you turn the solenoid into the on position, the pressure is allowed to transfer through the solenoid, obviously out to the valve body. So again, very simplistic as far as operation. These are high side driven solenoids, which basically means that there's going to be a bolt that bolts to the valve body that acts at the ground, and the controller actually sends voltage to the solenoid to make the solenoid physically function. When you get to the PWM solenoids, we're looking at the normally low solenoids here right now. The left-hand solenoid that we're showing you is shown in the off position. If you notice what's happening, the exhaust on that left-hand solenoid is basically open. The pilot pressure port right below that exhaust is closed. So that basically means we're exhausting the fluid pressure that's going out to the valve body via the solenoid. When we turn the solenoid into the on position, which is what we're showing you in the right-hand picture, the solenoid valve itself is going to be pushed down in this picture, as you can see, against the spring. When that happens, the exhaust is going to be starting to get blocked, and the pilot pressure port, as you can see, is starting to open to allow pressure to go through the solenoid to the valve body itself. So that means to us, in simple terms, the higher the duty cycle you have feeding the solenoid, the higher the pressure is going to be for the solenoid. When you in turn look at this particular picture here, this is showing you a normally high solenoid. So again, when we look at the left-hand side picture, we're showing the solenoid in the off position. When the solenoid's in the off position, as you can see, the exhaust is physically blocked and the pilot port is physically open. So now we have pressure output out of the solenoid. As we start to turn the solenoid on, we're going to start unblocking the exhaust itself. And of course, as we start unblocking the exhaust, that pressure that's at the valve body is going to start exhausting through that exhaust port, lowering the pressure. So again, the higher the duty cycle, the lower the pressure becomes in this instance. Bottom line, guys, is you cannot intermix the normally highs and the normally lows, just like you couldn't on any other transmission. And again, as I told you before, you're going to be really careful to make sure you mark the solenoids and mark the valve body to make sure you get the solenoids back in the same holes again. This is a look at the actual solenoids themselves. The top picture is the normally low solenoid. The bottom picture is a normally high solenoid. You can see there are a few little physical differences, but it would be really easy, especially if the guy's in a hurry, to mix these things up. So again, make sure you mark them so obviously you don't have to worry about it when you put it back together. There will be some markings on your solenoids. Those are markings for the manufacturer, and others for Jatco to use based on flow rate characteristics of the solenoid and so forth. Bottom line is they don't really mean anything to us. You will find different markings on different solenoids. And again, that's the reason you want to make sure you put the solenoid back in the correct passage. So here we're looking at the normally low solenoid itself. Again, same exact thing. You're going to find some markings on it. And again, those are only relevant to Jatco because they're the ones who designed this. The charts for basically deciphering these numbers are not available to the aftermarket out there. Here's an on-off solenoid. As you can see, as we talked about earlier, That on-off solenoid's got a bracket on it. The bracket is actually your ground for the solenoid. So we're going to send power to the solenoid to make the solenoid physically function. Again, just a simple on-off design solenoid. One of the things that's different here on this transmission with the on-offs is the on-offs are not just used to move you forward and backward like other transmissions. In fact, it really doesn't have anything to do with that. They're actually used to make some gear exchanges, some gear changes. So a little bit difference as far as operation as compared to what you guys have been used to with other 6-speed domestic type vehicles. We're showing you the solenoid apply chart. That should be popping up on your screen there. The low reverse brake, low clutch, those are your two on-off solenoids. As I just talked about, they're not just for moving forward and backward like they are on other transmissions. In fact, they don't have anything to do with moving you forward and backward. If you noticed here, what they've done is when you make the gear change from first to second gear, you're going to transition one of those solenoids. You make the gear change from fourth to fifth gear, you're going to transition the other solenoid. So again, a little bit different as far as operation is concerned as compared to other domestics that you've been used to dealing with. The other solenoids, as you can see, are your pulse width modulated solenoids. They're going to control a certain clutch as well as control the apply rate of that clutch. Now, let's take a look at our pressure switches. You're going to find the pressure switches here are kind of a throwback to what we had many, many years ago on many different kinds of transmissions, like a GM 700R4 as an example. The pressure switches are screwed right into the valve body, and the switches themselves are all normally open switches. They close at about 15 psi, and they're used primarily for adaptive learning controls. What we basically do with the transmission using pressure switches is when we cycle a solenoid on, we watch the pressure switch. When the pressure switch moves, we start measuring the period of time it takes before we see a speed sensor change. When we see that happen, we measure that time. That becomes your shift time, so we can either adapt up or adapt down based on that shift time. Now, I will tell you on the adaptive learning thing here, the aftermarket scan tools do not have a tremendous amount of information on the adapts, much less than their factory scan tools for Mitsubishi and Nissan actually have access to. So you're kind of limited when it comes to adapts on this JF613 if you're using a non-OE style scan tool. Again, the pressure switches are just like you're used to seeing on older applications. Again, normally open style pressure switch closes at about 15 psi, and again, it's basically used for triggering adaptive learning functions. When you look at the lockup valve itself, the lockup shift valve, as you can see, we're controlling that with the low reverse brake solenoid itself. So right now, the low reverse brake solenoid itself is in the off position. With it being in the off position itself, you have no pressure to the base of that shift valve, which means the spring shoves the shift valve down. Your pilot pressure goes through, becomes your lockup pressure, and of course your low reverse brake or your low reverse clutch through the low reverse clutch valve is going to be exhausting at this point. Now, when we want to make, obviously, this thing transition, we turn that low reverse brake solenoid on. When I turn that solenoid on, as you can see here, what we've basically done is we put pressure through the solenoid to the base of the lockup shift valve. When that pressure arrives at the lockup shift valve, now you're going to shove that shift valve up in this picture. When we do that, now your pilot pressure goes through the low reverse brake, and of course your lockup is exhausted. So as I told you, this is very similar to many of the Chryslers that are out there, where you're going to actually have a solenoid that controls TCC as well as a clutch at the same time. Your mainline oil pressure in this transmission is controlled by a line pressure solenoid. This, again, like we talked about earlier, is a normally high style solenoid run at a fixed frequency of 300 hertz. We're going to vary the duty cycle to it to vary your output pressure. This thing defaults to high pressure just like other transmissions do. So we're going to vary that red oil pressure coming to the top of that valve to vary what our actual output mainline oil pressure actually is on the transmission itself. Now, this will be one of the differences here that you're going to see popping up here on input speed sensors and output speed sensors from model to model of transmission. So Mitsubishi may not be the same as Nissan, which may not be the same as Renault, and so forth. Where they locate the sensors will vary depending on who the manufacturer of the vehicle is. how the sensors work is going to be the same no matter which manufacturer you have. So our whole point is these are Hall effect style sensors, and the Hall effect sensors themselves could be located in different spots, again, depending on the brand. But the function of the sensor and how you diagnose the sensor will remain the same. Here's a look at my input speed sensor. As you can see here, input speed sensor is right next to the Prindle switch. You're going to pick the input speed sensor reading up, as you can see, off of the low clutch drum. That's where your input speed sensor reading is going to come up from. You may have different locations again for some of the sensors like we're showing you here. And your output speed sensor reading is going to pick its information up off of the output gear. So as the output gear rotates, of course, we're going to pick up our speed sensor signal. Now, as I told you earlier, this is a Hall style sensor. And being it's a Hall style sensor, you're going to have ground and voltage sent to the sensor all the time in order for the sensor to physically function. So we've got a 12-volt signal that comes from your automated transmission control relay, and in turn you're going to feed your voltage back to your TCM via the signal voltage. So bottom line, guys, is this does not work any different than a regular vehicle speed sensor that's a Hall style sensor in anybody's car. You will have trouble codes set for it. If you have a default, obviously, in the sensor, in other words, a defect in the sensor or the wiring, on the output speed sensors, you can see it's going to be code 720. On the input speed sensor, you're going to see there's going to be a code 715. So again, it does not make any difference which of these sensors you're talking about. The only thing that's going to vary on them is going to be their frequency because of the number of teeth, obviously, on the reluctor wheel or the output gear that you're going to have that you're going to pick the signal up from. So again, diagnostics are the same no matter which kind of car you have or where the sensor is located at. The only difference is going to be where you actually find the sensors. The Prindle switch is kind of a unique Prindle switch in these cars. I kind of like this whole idea. If you notice, the voltage is actually being sent to the Prindle switch via a relay. So that's what we're showing you in that chart that you see right there. It says pin 3 voltage comes from your ECU ignition 1 relay. So we're going to send voltage to the Prindle switch itself all the time, and then as you move it through different gears, the contacts in the Prindle switch will feed that voltage back to the TCM based on which gear you've actually selected. So that chart shows you who should have voltage and when they should actually have voltage. A little different approach as compared to some of the other cars that you've been used to working on where the Prindle switch is actually the ground for the circuit, simply pulls the lines low. So again, different approach. The one other thing that I do really like about this Prindle switch design is that they make the switch adjustable. In America, one of the things we run into quite often is the EPA puts a lot of pressure on manufacturers to make things where they're non-adjustable. Because the theory is if they're adjustable, that also means they're misadjustable. So the bottom line is they would like to have everything non-adjustable. Well, in this instance, as you can see, the Prindle switch is adjustable because this thing is sold not only in the continental U.S., but obviously across into different countries and so forth. So bottom line is kind of a nice little feature that we're actually not used to seeing. Now, when it comes to getting the valve body out of one of these transmissions, you're going to have to push the harness into the transmission body itself in order to get access to the valve body. So there's my point is the harness is actually pushed inboard. There will be a retaining clip on this harness to allow you to push that harness inboard. So in this instance, as you can see, that retaining clip we pop off, shove the harness inboard, and at that point, we'll be ready to take the valve body bolts off. Now, I'm showing you a picture here showing you which bolts you actually have to remove. And the logic behind that is just like any other valve body, or you don't want to take all the bolts out because you're going to have a big mess on your hands. So these are the bolts you physically remove to be able to take the valve body off. And when we talked about the fact that you cannot buy a solenoid for these right now, you're going to have to service it as a valve body assembly. And we're starting to see these come into shops. So again, I'm assuming you're going to see more and more of these transitions as the days go by. When you want to air check one of these boxes, you're going to use regulated air pressure just like you would any other transmission. Nothing different about that per se. When it comes to the passages, we're showing you in your handout which passages are where, so you'll know where to apply the air pressure to get the different clutches to physically function. We do have some line pressure taps and apply pressure taps on this transmission. Again, I wish everybody had these apply pressure taps. They don't, which makes our job much more difficult. There is an adapter that Mitsubishi has for getting into the 3.5 reverse tap. Again, you may not have to do this. You just get a die grinder out. I think you probably just die grind the case a little bit and get right into where that tap is actually at. But if you do decide that you want to buy the adapter because you're doing a lot of Mitsubishi repair, then this is the adapter part number for you so that you can do your check on that 3.5 reverse passage. We're going to show you each of the passages in here so you know where they'll physically go. As you can see, the low pressure passage is next to the Prendl switch and the input speed sensor. We whip the transmission around, so we rotate it around. As you can see, 2.6 brake and high clutch are right here. We rotate it around again. So obviously at this point the pump is facing towards us. As you can see the pump in the upper left-hand corner of that picture. That's where you're going to find your 3.5 reverse tap. This is the one that you may need to have the tool for, or else you're going to have to do a little massaging of the case right there to allow you to get your pressure gauge in. Again, the nice thing about having an apply pressure tap is you can actually check what's going on in the clutch because it's pressure after the protection orifice for the clutch itself. So real handy things to have. Now, you're going to be some tools you have to buy if you're going to work on one of these. The tools you're going to need to buy is what they call an e-Torx, which is a special type of Torx. If you noticed, a standard Torx, which we're showing you there in black, that's a Torx socket there in black, a standard one, is tapered on the end. The e-Torx are not. They're flat. And they're designed so that you can get a hold of the e-Torx bolts. So if you try to use a standard Torx socket on it, you're not going to get on all of the material on the bolt itself, and a very good chance you're going to end up stripping the head on the e-Torx bolt. Two ways you can do this. There are some companies like Snap-on right now who is building these e-Torx sockets, or you can go down to your local Harbor Freight store or wherever else you wanted to go and physically buy yourself some cheap sockets and take them to the belt grinder and basically sand the socket down until you get rid of the taper on the end of the socket. It'll do the same thing for you. Now, there are three sizes of Torx sockets you're going to need. You're going to need an E20, an E16, and an E18. Those are going to be essential for even getting this transmission apart. So again, it's real important that you have access to an e-Torx socket to allow you to take this transmission apart. Now, about the only other razzle-dazzle thing you got to be aware of is if you have an all-wheel drive application, the stub shaft has to be pulled with a puller or a slide hammer to get, obviously, the transmission and transfer case separated from each other. If you don't do that, you're going to have a heck of a big mess on your hands. So the stub shaft itself is actually threaded. In the end of the stub shaft, there's an 8mm hole with a 1.25 thread pitch that you can slide screw a slide hammer bolt right into and physically slide hammer that shaft out of there. The logic is there's a retaining clip, a compression style clip on the end of the shaft just like you would have for a regular axle shaft that you would deal with. So again, nothing different here than other transmissions other than the fact you're going to have to slide hammer that shaft out. When you do get ready to go back together, there will be some seals that seal between the transfer case and the transmission. You're going to make sure those seals have been replaced as they're in position, or you're going to have a pretty massive leak between the transmission and, of course, the transfer case. All right, about the only thing other that you have to pay attention to is going to be your sprag, the one-way clutch in this transmission. We're showing which way it goes. We're showing it here on the bench. We're saying it freewheels counterclockwise and locks, of course, clockwise. Now, when we show it in the transmission case itself, like we're showing you here, same exact rotation, going to freewheel counterclockwise, going to lock clockwise. So that pretty well takes us through all of the things that you need to know to get your first chance of working on one of these things. You won't be kind of overwhelmed with them. There really isn't a whole heck of a lot here, per se, other than like we talked about the valve body differences here a little bit. But effectively, when it comes to actually working on the unit, there's not a lot there. Again, we'd like to say a big thanks to the folks from CL Aftermarket Products for sponsoring our webinars. The next webinar for you guys, just so everybody is aware of this, is going to be on Toyota reprogramming. So we're going to do a Toyota reprogramming webinar on June 4th, and that will be our next webinar that we actually have coming up. So until then, guys, I don't see any questions popping up. You guys have yourself a great week, and we'll see you in 2 weeks.